Okay, so now that you've learned how to calculate variance, I'm going to just take this one little step further. Sometimes students say that, well, I get variance, but then there's this whole other set of problems that you give us where you only give us the probability. You don't give us a whole data set. How do I handle that? And the idea here is you're supposed to be able to kind of figure it out, but that's okay. It might be a bridge too far, and I understand that. So let me give you an example of what you're supposed to see and how you apply it to the problems where they just give you probabilities. So the big idea here, let me give you a really silly data set. Let's give you just a couple values. We'll give you 0, 0, 0, 1, 1, 1, and 2. Okay, so to calculate the variance, the first thing we're going to need is the mean, so let's go ahead and do that. Oh, I will point out, do you notice I am using the population version, so it has the n, not the n minus 1, just point that out. Okay, so the mean. This comes out to be 5/7. The mean is 5/7, which is approximately, let's just call it 0.71 for just this example, just so you can get the big idea. Okay, so now, if we're doing this calculation, I really, really hope you would not do this. I'm really hoping your math skills are better than writing out 0.71 squared plus 0 minus 0.71 squared plus 0 minus... What you're doing here, I'm hoping you're not doing, is you should realize, look, I'm doing the same calculation 3 times. I'm not going to write it out 3 times. I'm just going to write it as a times 3. So therefore, all we have to do now is write out a few things, and then we're going to be all ready to go with the problem. All divided by n. So there we go. So hopefully, well, excuse me, an n is not n is 7. There we go. So now hopefully you did that. So the idea here, what you're hopefully should be seeing on the next problem that looks something like this is, well, here they don't give you the individual data values. They just say 0 happens 10% of the time, 1 happens 60% of the time. Well, if you were to take this variance problem, excuse me, if you were to take this right here and think of it as little individual fractions, so this would be 3/7 of 0 minus 0.71 squared, this would be 3/7 of 1 minus 0.71 squared, and so on and so forth. Do you see that what we're really getting here is little probabilities? That right there is the probability of us getting a 0. This right here is the probability of us getting a 1. And this right here is the probability of us getting a 2. So we don't need a new formula. We don't need any new techniques. All we have to realize is our variance formula is slightly different. When we're writing it with probabilities, we're going to skip that whole fraction part. All we're going to say is, all right, it's the probability of my first thing times the value minus its mean. But in this case, we don't calculate mean. We would calculate the expected value. Sorry, x1, there we go, squared. And then it's the exact same formula that you're used to doing. So now it would be the second value minus the expected value squared. And we have 4 values, so this would continue out for 4 values. So to do this problem, and then we don't need the divided by n because that's taken care of in the probabilities, right? If you think back to here, our n was a 7, and then when let me get a little barrier in there. That didn't work well. There we go. Just inserted a little space. There we go. So remember, this divided by 7 was the denominator of our probabilities. So when we have the probabilities, that's all we need. We don't need to worry about anything. So that's our whole formula. It's fantastic. It's so much easier. So the variance here would be the probability of the first thing would be 0.1 times the value of the first thing, 0, minus, well, what's the expected value? When I calculated it, I got 1.4. So then plus the second probability, so that's 0.6 times 1 minus 1.4 squared plus 0.1 times 2 minus 1.4 squared, and then last but not least, 0.2 times 3 minus 1.4 squared. And once you figure that out, you have your variance. So therefore, obviously, the big idea here is to get standard deviation. You would just take the square root of both sides and be happy that it's so easy to do. All right, so I hope that helps. So for these probability problems, the idea here is you're just using the same formula you've always used. It's just augmented a little bit. I hope that helps.